Hello, everyone, and welcome to this episode of Crowded Beaker Solves. Today, I'd like to do a type of problem that I very often see when I'm teaching my AP Chemistry students. This type of question is a question that appears very often on AP exams, AP practice exams, progress checks, review materials, that kind of thing. And first, let's read the question and we'll see why it's kind of a challenge. So, the question here I've proposed is which of the following has the highest mass percent of oxygen? And then there are four choices. Now, in our previous video, we learned how to do mass percent, and we spent some time calculating a mass percent. The challenge here is that this type of question usually ends up as a multiple choice question. And when you're doing a multiple choice exam, you really only have a limited amount of time to answer a bunch of questions. For example, on an AP exam, it's typically around 90 minutes for 50 multiple choice questions. That's what it is currently. And so you really only have like a minute and a half or a little bit more to answer this question, which has four things you have to figure out. So the key here when seeing a problem like this is to remember your mass percent formula and also try to keep it quick and dirty. Just don't worry about all the digits that your periodic table is going to give you. Just get something close, round your numbers, and then move on. So, for example, if I want to find the mass percent of oxygen in each one of these things, the tempting thing for me to do would be to say, well, I can narrow it down to these two because these have two oxygens in them and the other ones only have one. While that is tempting to do, please don't do that because you're probably going to run into errors. We can't necessarily tell unless we're just really familiar with all the oxide elements, compounds, which one is the highest percentage. So you just have to figure it out. So for the lithium oxide, I'm just going to go ahead and do this quickly to show how I would do that. For the percent oxygen in the lithium oxide, I'm just going to say, all right, oxygen is 16 grams. It's like 15.999 something on the periodic table, but I'm rounding. And I add up two lithiums and an oxygen, and I get 29.9. All right, times 100, and that comes out as 53.5% oxygen in that compound. Quick and easy, just round your numbers and save yourself some time. In the silicon dioxide, I ended up with 2 times 16 grams of oxygen because there's two of them over the total, which I calculated to be 60 grams of silicon dioxide. Multiply that by times 100, and it comes out as 53.3. And I didn't mean it to be that close, but it ends up being close. But I can see one is slightly higher than the other one. And then we have to just continue on. Let's do lead oxide here. 16 grams of oxygen over 223 grams of lead oxide. Again, I'm rounding those numbers. Save yourself some time. This one only works out to be 7.17. Let's call it 7.2% oxygen. I don't really need to worry about sig digs here. And then finally in the SO2, 2 times 16, and that's over 64 grams of SO2 times 100, and I end up with just about 50% oxygen. Okay, so you have to do it 4 times. There's no way around it. You just have to quickly do it as quickly as you can. And when you get your final answer, we find out that the highest mass percent of oxygen is in this one. So that would be the answer that I would choose. Remember, about a minute and a half per one of these questions. And if you need to skip it, come back to it, and that kind of thing. So I have one for you to try to solve yourself. And I'll put it up here. Which of the following has the highest mass percent of sulfur? Feel free to pause the video, take a moment, and see if you can do this in a minute and a half, 2 minutes, and then we'll check our answers in 1 second. Forgive me, my light's turned off on me. Okay, so if you were able to do it and find out that the SO2 has the highest percentage of sulfur in this group of compounds, then congratulations, you did a good job. Let me adjust that slightly. And it turns out we do the same thing. There's only 36% sulfur in the FES, only 13.8 sulfur in the HGS. That's because Hg is a massive element. And something in the middle here at 29%, and then the sulfur in the sulfur dioxide happens to be just about half of the mass of the compound, or around 50%. So there you have it. Quick and easy calculation. You got to do it quickly, round your answers, move on to the next question. If you have any questions for me, or if you have a suggestion of a problem you'd like me to solve, feel free to add it in the comments. Otherwise, in the meantime, happy solving and have a great day.